Good morning, everybody. My name is Keiran Greening. I am a safety advisor with the Saskatchewan Construction Safety Association. I'm here today to have a toolbox talk with you on electrical safety for non-electrical workers. So to introduce myself, like I said, I'm a safety advisor. I work out of the Saskatoon office. I deal with a few different regions of the province. So I deal with Prince Albert, a little bit west of Saskatoon out to the Macklin area, east of Saskatoon out to Humboldt, Wadena, and Wynyard area. And then I also deal with companies in the Saskatoon area. So without further ado, we'll just jump right into the presentation here. So this is to start off, we'll go with a basic introduction into electricity, talk about what electricity is, because electricity is seemingly magical. We have this intertwined power into every facet of our lives. We've put ourselves into situations where we can't live without power nowadays. It can be defined as a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically as an accumulation or a charge as dynamically as a current. Since we use electricity for so much, it's important to understand what those hazards are. But before we get into the hazards, we're just going to look at what some of the basic points of electricity are. So in electrical current, the number of electrons motion is called amperage, or current. So that's measured in amps. The pressure pushing the electrons is known as volts or voltage. For instance, a generator spinning at 1,000 rotations per minute might produce 1 amp at 6 volts. So you can imagine it as a water hose. So if you have a water hose of a certain diameter, let's say it's an inch across, and you have some water flowing through, the actual water is the amps, and the pressure pushing the water out of the hose is the voltage. So if you hear 10,000 volts and 3 amps, you have 10,000 amps, or 10,000 volts, pushing those 3 amps. So in modern electricity, we use high voltage to push low amps. And it can also be said that high voltage in Saskatchewan is determined by anything having a higher voltage rating than 750 volts. So we're going to talk about DC, or direct current. So in these circuits, you're going to have a positive and a negative. So if you look at the negative terminal, the most common, well-known example is a car battery. So if you look at the car battery, there's a positive and a negative circuit, or pole, So the positive is the end point, and the negative is the start point. The electrons flow, or the amps and electrons flow from negative to positive. So when you take a look at the whole system, you might notice that it seems like it's kind of magical, but on a very simple level, it's like water flowing from point A to point B. And if there's some sort of device it has to push to get to the point B, it's going to use it. So electricity will power your electronics, instruments, little electronics in the car, the 12-volt charger, with that one circuit. So it'll go from point A to point B. It's also worth noting that when you boost a vehicle, it's always paramount to ensure that the red, or the positive, goes to the positive terminal, and the black, which is the negative, goes to the negative terminal. If you switch these and you put it the other way, the battery is at risk of exploding for the fact that you're charging the positive terminal with negative electrons. So it reverses that flow and changes the dynamic of it. This is something you don't want to do. Other examples of DC current, some images on the screen. There's obviously a lot more, but most small electronics that are battery powered, laptops, phones, mouses, keyboards, they all have direct current. So one of the most common things as well is alternating current, or AC. So in the picture there, you'll notice a light bulb, plug-ins, an extension cord, a light switch, a temporary power setup that you might see on construction sites in Saskatchewan. So this is what powers all energized or most energized homes in North America. So it's typically more dangerous due to the fact that we use a lot higher voltage to push these electrons. So AC is the voltage that we're most likely to encounter. So we're going to jump straight into the hazards now that we know a little bit about the rest of it. So when electricity creates a hazard, it is capable of doing a lot of damage, as we saw in Star Wars when Emperor Palpatine toasted Luke Skywalker. But on a serious note, there are many dangerous situations a person can put themselves into when there's a lack of awareness of some of the basic hazards. So we're going to go over some of those basic hazards. Just a note that these are not an exhaustive list. These aren't all of the hazards. These are just some of the common ones I chose to include today. So we're going to talk a little bit about extension cords, which of course come in all different shapes, sizes, plug-ins, as you can see in that picture there. Some extension cords come with a ground slot, some have 2 prongs, come in different gauges. So it's very important to understand the risks involved when we use these cords. So the gauge of a cord refers to how thick it is. The most common cord gauge is 14 gauge. So when you take a look at the gauge, it might be a thicker cord, but that could also be the insulation or the plastic coating on the outside. So what you want to do is refer to the tags when you purchase these things to make sure that the amp rating is adequate for the cord, because some of them will require a larger gauge. For example, a block heater on a Ford F-150 requires a higher amperage than a smaller vehicle. So if you take and look at the amp rating, you might need a bigger cord. And if you don't have a bigger cord, it's going to pull more amps through a cord that can't handle it, creating heat, which in turn creates a fire hazard. As well, a common situation is if you have 50 foot from the power source to your tool, and you only have 2 25-foot extension cords that you're going to attach them. So that is also a fire hazard. When you put the resistance of the cord together at the plug and the block, there's resistance. So the more times electricity has to flow through a different area like that, it will create heat, which in turn creates fire hazards. And then the most common things we see on construction sites is damaged cords, frayed. If the bobcat ran it over, they get flattened, pinched. If you put them through the window or a door, they get pinched as well. So it's just common to see different types of damage, as well as a missing ground. If the cord has the ground wire, it's very important that it does not get used without that ground. So extension cords should be inspected prior to use. It goes without saying. If they're damaged and let's say you're outside working, it can become a hazard of shock with the water. And damaged cords should be removed by anyone who sees it. And then if they are going to be repaired, by a qualified or competent person. Or of course, the alternatives to dispose of it. So we're going to talk about a short circuit. This is a pretty common term outside of the actual use of what it is. So this term is most commonly used by electricians to refer to a situation in which a hot wire carrying live current touches a neutral wire. This can happen when resistance lessens and instantly a large volume of current flows through an unexpected pathway. As you can see here in the picture on the right, it's depicted a full circuit, but in the middle, let's say hypothetically that's a second wire crossing, and it touches both those wires and it causes a short. Otherwise, you might see a spark or it could start a fire. It just generates heat without, usually it's an uninsulated source. So we'll just give an example of that. So if a worker is carrying drywall studs through a construction site and there was exposed wire coming down from the roof and electrician or someone else tampered with it or forgot, many number of situations can happen on any construction site, and that's part of the hazard assessment process. So if that stud touches those 2 wires, it could potentially send a shock down that metal or any other piece of equipment that may conduct electricity. So with any good hazard assessment, we want to take a look at all the risks. We want to ensure that our workers are working safely, and that goes hand in hand with due diligence to do everything we reasonably can to protect the health and safety of our workers, ourselves, and everyone else on site. So this isn't so much a hazard, but a protective device. So this is a ground fault circuit interrupter. So there's two here, two different types. So if we take a look at the one on the left, it's an outlet. So this is most commonly used where water is present, such as a bathroom, any other area near a sink in the kitchen. It's best practice to have that there. In some situations where a lot of water is present, an interrupter on the breaker panel may be used. So the difference primarily between these two is that on the one on the left, only the device will be protected, whereas the device on the right, the whole circuit will be protected. So if there's a light fixture, if water leaks through the ceiling and goes down, it'll just short out instead of causing serious damage. So these devices are to help ensure that you don't get electrocuted, which means shocked to death, of course. So I just want to take a minute to talk about power lines and power line safety. So power lines run above sites, just as depicted in this picture here. It's not a construction site, but you get the picture. There's also cables like this running beneath the ground. And in both cases, hazards are present for operators of equipment, people drilling, boring, any sort of ground disturbance. And like I said, part of any good hazard assessment is to ensure all hazards that are serious are controlled. So this can include work with those power lines. Section 22 in the OH&S rules and regulations sets out a table with a whole bunch of different numbers relating to how close you can work to a power line if you're trained as an electrical worker. And if you're not, since the vast majority of us in the construction industry are not electrical workers, it's our best practice to ensure at minimum we stay away from that. But also things we can do is contact Sask Power or whatever company is managing those lines and ask them what they can do to potentially, because they may be able to insulate a line, take it down temporarily if it's going to be a sure issue, and that way they can reroute it without incident. And as well for below ground, in Saskatchewan, getting line locations to dig is a regulation. If an underground line of any sort is contacted, energy can be released and cause serious injury. Not only that, but that's an OH&S reportable incident that they will ask or they will expect you to report on. So I'll just quickly read from the book legislation that says this. So section 259, an employer or contractor shall accurately establish the location of all underground pipelines, cables, conduits in an area where work is to be done and shall ensure that those locations are conspicuously marked before commencing work using power tools or powered mobile equipment on an excavation, trench, tunnel, excavated shaft, or borehole, or before breaking ground surface with any equipment to a depth that may contact underground utilities. So underground utilities can be anywhere from a foot to quite a bit deeper than that in the ground. So it's very important that we get those lines located. It's also worth noting that Sask First Call only does primary lines. So secondary lines ran by other people, different services that might not show up on their with their devices. You'll have to contact a third party to ensure that those lines are also marked before you dig. Because just because it's not a primary line doesn't mean it's not potentially dangerous to your health. So I want to talk about some electrical safety tips. These are just some best practices. Testing before you touch a live wire, or any wire that is. Treating all electrical wires as if they are live, that kind of goes hand in hand with that. Inspecting electrical cords, plugs for damaged insulation, broken ground wire pins before use. Reporting all exposed electrical parts, including wires, terminals, missed circuit breakers, immediately. It's important to the health and safety of everyone on site that if there is live power, if you notice exposed electrical, that you ask that question before work starts. Don't be afraid to ask your supervisor. It might just save a life. So we want to store our materials and equipment more than 10 feet away from overhead power lines, just because there's a chance of arcing. It depends. Some people might have to climb on top of different stacks of pallets or anything like that. So if there is quite a height to it, it's best practice to store stuff quite a distance away. So you want to replace those extension cords or fix them with a qualified person when damaged. Never use nails or sharp objects to hang extension cords from ceiling or walls. Use brackets or things that are sold to hang the devices, as well as if you're going to drill into the walls, make sure you know where power sources are. Never run electrical cords through the window. Like I said earlier, there's the pinch points. Instead of connecting strips or surge protectors to extension cords, use a 3-way extension cord with a GFCI or a ground fault circuit interrupter. Keep floors, work surfaces dry to avoid the chance of electricity flowing through the electrons in the water, and regularly inspect electrical tools and equipment for damage. So just to wrap things up here, I want to thank you all for viewing this video. It's been a great pleasure making this video and talking about some of the hazards. You can join us tomorrow for our next edition of Webinar Wednesday, where the topic is going to be on radon awareness. So important because that is the second most leading cause of lung cancer in Canada. So check that out tomorrow and we'll see you then. Thanks so much. Have a great day.